Good morning, everyone. My name is Tutuzile Kubega. Welcome to Life Sciences Grade 10. So guys, I'm going to use just today's lesson for a quick recap of the work you should have done or you 10. So it should be revision for you actually. And then we are officially starting with term 3 this term. I am Tutuzile Kubega, your new teacher for Life Sciences. So today I want us to cover the topic of support systems in animals, particularly the skeleton. I never thought much about skeletons until life sciences, would read some of the main types of skeletons found in living things are the hydrostatic, endoskeleton, and exoskeleton. Hydrostatic, the word gives it away. Hydro has to do with water. Endoskeleton meaning inside, and exo means outside. Each of these skeletal types have advantages and disadvantages. So different animals, and even different animals would have different skeletons depending where they are situated or based. It wouldn't make sense for, let's say what example? Let's compare two animals or organisms that we know. Compare a snail and compare a snake or a human being. If a snake had as many bones as we do, it does. You understand? So the main purpose, the main overall conclusion here is that and our body types are so adapted to the environments we are living in that they have to be perfect and accommodate that type of environment. Skeletal structures are adapted for the transition from an aquatic to a terrestrial existence where greater support was required. So in the aquatic environment, they don't have as much skeletons as in the terrestrial environment. Why? In the water, you don't need much support. It's easy, it's flowing, it's free. But on land, you need it to balance yourself, to move, to walk, all of those things. The human skeleton consists of the axial skeleton and the appendicular skeleton. And the main purposes of the skeleton are to allow for movement, to provide protection, provide support, produce blood cells, and allow for hearing. Who knew that? That part over there, who knew this one? That allow for hearing. You see, we have skeletons. We can't just think of skeletons as the ones on our legs and arms. Skeletons are all over our body, right? So they play various functions. It plays a particular function in that area in your body. So here, like I just said, what you need to remember each time as we move through this information at all times, especially with life sciences, the one thing that is always emphasized is structure is related to function. Now, it is important to understand the relationship between structure and function. Bones, cartilage, tendons, and ligaments. Joints, what? They connect when you hear when someone complaining of their joints and all those things, we need to understand the differences in these and how they function here. Because sometimes we use them interchangeably as though they were the same thing. Joints connect pieces of and allow independent movement of neighboring pieces. There are three types of them. They are fixed, they are partly movable, and they're also freely movable joints. Freely movable joints are also called the synovial joints, which are of either ball and socket, hinge, pivot, or gliding structure. You're in grade 10, so I'm sure you remember these, especially the hinge, the pivot, and gliding structures. You did a lot of these when you were still doing technology. You remember when different structures. But it just shows you the main point of the joints, like the word is saying, it's a joint, it joins together pieces of skeleton. So you understand? Joints, that's the word, it gives it away. Hope you understand that. And then the skeletal muscle is attached to the skeleton through tendons. And the structure of voluntary skeletal muscle is made up of myofibrils, which allow for muscle contraction. This contraction is then used to move part of the skeleton. So you understand how eventually movement happens. It is because of the skeletal muscle, which is attached. It is attached to the skeleton. The skeleton on its own can't survive. It can't do anything. You know, when in exhibitions, and probably you have it in your classrooms, you'd see the skeletons put up there. And unless you move the skeleton structure, nothing else happens. So a skeleton alone can't really do much. It needs to be attached to other things that work together in the body for it to function properly. Right now, we've just discussed the skeletal muscle. Then we know of diseases that affect the skeleton. Diseases that affect the skeleton would be rickets in children, and then we'd have osteoporosis, arthritis in adults. Those ones affect the skeleton part. And if it affects the skeleton, that means it affects a lot of functions, like we just said in this previous one. The main functions of the skeleton are what? To allow for movement, to provide protection, provide support, store minerals, and allow for hearing. Now, when you've affected and you have a problem with your skeletons, means all of these functions listed here are affected. And then that's a big problem for you and your health. So you understand how important it is for us to take care of our bodies, take care of ourselves, be mindful of the foods you eat, the things you do, you know, sometimes even extreme sports. But yeah, guys. Okay, skeleton. Now we'll delve into the main part now. What is a skeleton? Let me hide that answer. Who knows? Does anyone want to answer me what a skeleton is? Define. If you were to ask to write a definition of a skeleton, what would you write? Because I think it's clear, right? You know what it is, but how do you explain what it is? Anyone willing to give me an answer? In my classes, guys, please, I really prefer when we engage. It's nice, man. I get feedback from you guys to understand and see and get to know you. It also helps me to get to know you guys, né? So please, can we talk to each other? Anything, tell me what you think. How, if this was an exam, how would you answer the question, what is a skeleton? So that we can assist each other out. And don't worry, you can't be scared of anyone anyway. We can't see you. We only see your name there. We don't really see you. So shoot away, ne? So feel free. That's the what I wanna say. Feel free. If I move too fast, stop me. If I move too slow, also tell me. If you know certain things, you are free to comment on whatever. Just you guys. So since no one is going to tell me what the skeleton is, the supporting structure of an organism. There are 3 different types of skeletons. I've already covered this. Guys, before I even continue, actually, did you do this work that I'm covering right now? Everyone in the chat box, give me a yes or a no. If you have done this topic, raise your hand. I just want to see just any form of response so I can see how many of you have covered this section so that I can know if I should just flow through it quickly or I should really explain. Oh, hi Phil, I see Pile. Pile, right? I'm saying it correct. Pile is explaining to me what a skeleton is. It's an framework of the bone. Okay. Quickly, I see Sharon has given me an answer. Pile is also no. Quickly, everyone, please, if you don't want to type, just raise your hand if you've done it. I just want to see how many people actually covered this topic. B-Max, Busi, Ingrid, Joey, Lindelwa, Lucian, Poppy. Please, guys, talk to me. No, all of you know. Okay, I'll take it easy then. I won't move very fast. I'll take it easy with this one. Okay. So I see a lot of no, so it's okay. I'll take it slow. I'll move through it. I won't. I was under the assumption it's revision, but okay. Since it's term 2's work actually. But anyway, what is a hydrostatic skeleton? Hydrostatic skeleton, we hear that water exerts pressure on the muscular walls. In this type of is exerting pressure on the muscular walls. For example, in the jellyfish, you know the jellyfish? That is an example of an organism with a hydrostatic skeleton. And then an exoskeleton, the stable, chitinous or mineralized outer shell of an organism. Shell of a grasshopper or a prawn. So you know those organisms, now you know a grasshopper. It's made up of an exoskeleton. So it has like an outer shell. Then all the organs are protected inside. Even the prawns, they are very hard. They have a hard shell. Prawns as well as, what is it, the crab, you know, the shell is hard. And then inside, if you were to open it, you'd find that it's soft and mushy. Understand that? So those organisms have an exoskeleton. And with an endoskeleton, this is a cartilaginous or mineralized support structure inside the body. These are keywords. Remember, endo means inside, exo means outside, hydro means water. So remember those keywords. With this one here, other vertebrates that we are familiar with, your animals, your dogs, your cows, they have an endoskeleton. So our skeleton structure is inside our bodies. It's a support structure for us. The exoskeletons, the outer shell, it's outside. The shell is outside, protecting. It acts as a shell, rather. Let me say that. An exoskeleton is all those animals or organisms with shell. It protects them. Then hydrostatic, those ones who with the way in their most of the time, like we said, the jellyfish. Pile, you want the link for what? For this class? I'm not sure what you're asking. Please explain. And then the evolutionary, YouTube. I'm not sure. Our host will tell us just now. But if you can't find trouble, search for Africa Teen Gigs and then you'll find Life Sciences Grade 10. Ne? But I'm sure we'll post it now. Please, if you can, share the link. Pile is looking for it. I'm not sure. Okay, the evolutionary development of the skeleton. We have the body support provided by water. Here, with the one we are discussing now, this is the body support provided by water. We are doing, so we are explaining in detail how the developed over time. The earliest forms of life evolved in the oceans. The fact that this is an aquatic environment is key. Remember that aquatic in the oceans, it's an aquatic environment. So this was the very, very beginning. Know about water. It is about 1,000 times denser than air. You get that? The high density of water allows organisms to float due to a physical upward force inherent in liquids known as buoyancy. So because of the buoyancy, organisms or things in the water would most likely float. It allows them to float. That's why others, when you swim, you can float because you understand, it has the upward force. Water has that upward force. So that's the characteristic of water. Buoyancy, what else does buoyancy do? It allowed organisms to grow and reach large sizes because the buoyancy supported the body weight of these organisms. So when those organisms and they would reach very large sizes, you'd notice with maybe these tuna fishes, the whales, they get really, really big. Ne? It's because of that. That still can really apply to them. What else does the water do though? The density of the water also provides resistance to movement. And animals had to adapt to ensure that they were able to move efficiently through water. So this is the basic science of water and what it does and its characteristics. Ne? So we understand that water is about 1,000 times denser than air. So it's denser, it's dense, it's heavier than air, if we can put it in layman terms. It also is what? It allows organisms to float because physical and upward force, this water, which is called the buoyancy. Because of this buoyancy, organisms are allowed to grow and reach very large sizes, so they can grow. It supports the water, it supports large body weights. That's why anyone can swim, no matter how big you are, you swim and you feel lighter. No matter the different body masses, we all swim and we feel lighter because the body supports different types of people for all things actually. So you can be able to do that. So what else? This density also provides resistance to movement. That's the thing. So you can't just move. That's why animals had to adapt. So the animals over time adapted so that they can be able to move efficiently through the water. And then, what is this? An early adaptation by organisms was the ability to change the hydrostatic pressure chambers of their bodies to enable quick movement. So, because of this adaptation to change that hydrostatic pressure, there had to be changes in the body of these organisms so that it allows them quick movement. So it's not just, that's how the evolution happened. There had to be changes in the body to this environment it is in. This resulted in what? In the development of hydrostatic skeletons. Animals with this type of skeleton include what? It includes jellyfish, includes the octopus, and includes the sea anemones. So you know when you look at these types, you can clearly picture how a hydrostatic skeleton is like. Ne? The change in shape of the animal reduces both the friction and the drag because you see it just moves smoothly because its body structure is adapted to be like that. For us as human beings and other animals, which are land animals, although we may swim in the water for a bit of time, our bodies are not designed to really stay in the water. That's why after a certain amount of time, you'd be tired because you are putting too much pressure into being in the water as you swim. Unlike these animals, they just exist and it's easy because of the development of their bodies and this hydrostatic skeleton. It's easy to move about in the water. It's not even work for them. Just like how we would walk and you are existing on land, that's exactly like them. Our bodies are designed to survive and exist on land. Theirs is built to survive and exist in water. Here's that image of the jellyfish, which uses muscles to contract against the hydrostatic skeleton to bring about movement. So you picture this, you see it? That is how it is like. So it moves, you see, with a structure like this, movement is easy, movement is free. Over time, in order to refine movement and improve protection from predators, some organisms developed a hard, chitinous exoskeletons first developed in the aquatic environment in ancient arthropods. You remember arthropods, right? Animals with this type of skeleton include crustaceans. You know crustaceans include crabs, lobsters, prawns, you know, those ones with the hard shell. Those ones are the crustaceans over here. Why did the exoskeleton form? What did we just learn here? The exoskeleton formed because they had to refine their movement and also improve their protection from predators. What would predators do? Probably they were at risk because it's a man, it don't eat well out there, especially even in the water as well, even in the oceans. Other fish or other sharks or other organisms are going out to get food to eat. So those other organisms now wanted and they developed an exoskeleton. So that was a preventative measure. It's a protection shield rather, so that it's not so easy to grab them and eat them because of that exoskeleton. Eh? So that's one of the reasons this developed. So like I said, with the crabs, the lobsters, the prawns, that's your example of exoskeleton here. This is an example of crustacean. You see the hard shell. If you were to break the, for those who've ever eaten a crab or prawns before, you'd notice that as soon as you break open the shell, it's very soft inside. Né? And then eventually there were some animals that developed a skeletal structure internal to the body, which would become the vertebrate group of animals. These animals have an endoskeleton. Initially, all skeletons were made of cartilage, which is a dense rubbery type of tissue. You all know cartilage, right? When you're eating chicken or whatever, you see those ones, that one that is white, it's soft. Okay? It's not meat, it's not bone, it's just that white part. That is the cartilage. Okay? So it's dense rubbery type of tissue that initially this endoskeleton was made up of that. And then later, bones evolved. So initially it was the cartilage, and then later it was the bones. The adaptation now, remember we were first dealing with the aquatic environment of what happened and then how the transitions took place. Now, there was then an adaptation of the terrestrial environment. It started off in the aquatic environment. Please and follow up. And if you have questions, guys, again, feel free to stop me. Adaptation of the skeleton to a terrestrial environment. The two major requirements for survival on land are what? The development of a suitable support system and an air-breathing mechanism. So you need a suitable support system because how will you even stand, let alone move? How will you even stand on land with gravity there as well? And then an air-breathing mechanism. There. So when you're on land, because there's air, you need to be able to breathe in the oxygen. And because of the land, and we are walking on ground, you need to form some balance. So those are the requirements. So any animal organism that is existing on the terrestrial environment need to have these two characteristics. One of the biggest problems which are encountered by animals moving from water to land was the loss of the effect of buoyancy. You remember, notice the difference when you move out of the water. Let's say you were swimming to back on land. On water, for those who can swim anyway, you feel lighter, you can floating, it's nice. And then now there's just a certain heaviness in a way when land, because there was the loss of the effect of the buoyancy. In order to counter this loss now, animals then needed to develop strong limbs. Limbs are the legs there, and had to adapt the skeleton to support their body weight on land. Even very, very big organisms could really exist nicely. Land, you need a lot of support. The bigger the mass or the weight is, the bigger support is needed. Just think of it as this way: when you have to carry boxes, if you're carrying a light box, it's easier to move around and carry it. But as soon as you have to carry maybe 5 boxes at a go, then they're heavier and it's not so easy to move around. So that's somehow of what is happening. Now, moving effectively on potential. particularly if one needs to avoid predators, catch prey, or adapt to a particular habitat. These animals now, they're in the wild, they are, suppose what is it, an impala. You can imagine an impala with no balance to run away from the lions which try to catch it. Imagine an impala trying to go drink water, and then suddenly this alligator comes. You need to be able to be on balance. You can be able to run. You are alert. You understand that? So our bodies, guys, they're so amazing like that. They adapt to whatever situations we're in. That's the amazing power we have as organisms. You literally adapt or die. You understand that part? It applies in the life sciences. It applies even in real life. If you can't adapt to environments, basically it. After the move from the aquatic environment to the terrestrial environment, there needed to be an adaptation that took place. And it happened here, and you can see it in effect when you watch the animals and you see how it happens. Ne? Different skeleton types have solved these problems in different ways. So different organisms have solved ways, ne? Because it needs to fit that particular organism and where it's based and what it's faced with. Ne? So animals with exoskeletons like arthropods. Arthropods is a class of animals including what? The insects, the crustaceans, and arachnids. They transitioned from sea to land long before the vertebrates, which are the organisms with the endoskeleton. A major factor in their success was the exoskeleton, which provides attachment for muscles controlling locomotion. Remember, locomotion is the movement of appendages. Exoskeletons also provided some protection from desiccation, which is the water loss, because of that hard shell. That shell there, it's a protective structure, so it prevents the water loss. Then it provides ease of movement, or what we term. So it adapted. You see, the key point, I think the key point of what we are learning here is adaptation is key. And then this is an example. This beetle is an example of an insect. As you can see, insects have a protective exoskeleton that made it possible for them to colonize land millions of years ago. And they really did colonize land. Realize insects are literally everywhere, and they are surviving quite well because of the structure. But guys, I need you to remember that these changes did not just occur overnight, ne? Like we are saying, it's evolution. These are changes that occur from time to time, from generation to generation. So it could take over 100 years or million years, but the body is continuously changing. So the more time you spend in a particular environment, even your genetic structure is adapting to that environment, and it will change according to the changing environment. So do you remember when you did the topic of evolution? This is what is applying here. So it didn't just happen overnight. And then amphibians. Amphibians with endoskeletons, like frogs, live both on the land and in the water. You know that frogs, they can exist both on land and water. Ne? Their skeletons have adapted to give advantages in both conditions. So again, that's another advantage here. Oh, I'm sorry, let me go back to that slide. They can adapt and live in both conditions. How are structured different though? They have calcified bones to support their body weight under the force of. The skull is light and flattened for both motility on land and a streamlined shape for moving easily in water. Their pectoral girdle is adapted to give support for the forelimbs, which absorb the body weight when landing after a jump. So you see, whenever you study an organism in detail, because again, I will emphasize this, form fits function. In order, an amphibian wouldn't exist in both these different environments if it didn't have a structure exactly like this. And then this is a diagram of the amphibian. You all know a frog, right? There it is. These were the first vertebrates to colonize land. They begin their life cycle in water. Remember water when we have tadpoles, and then they emerged as adults. So you see how amazing this life cycle is actually. You start off in water and then you move on to land. It's really like, listen, guys, I think the more I learn life sciences, the more in love I am with nature and the wonder of organisms and adaptations. It's really amazing. It's and then their means of locomotion. Terrestrial animals needed to adapt their shapes and skeletons to overcome the effects of gravity. You remember I mentioned gravity? Yes, we need to overcome the effects of gravity because it plays a major role in our movement, our balance on Earth. Limbless animals, such as the snakes, had to overcome drag and friction because of limbs. They don't have legs. They can't just move easily. So they had to overcome drag and friction. That's why they are just a smooth shape, because then they can just really, how do they move? They glide along. Ne? That's how they can just move easily. Flying animals such as birds and bats, light skeletons and very strong sternums for wing muscle attachment. With bones heavy and they're weighing you down. That's why birds, those ones that fly, have very light skeletons. So they do have skeletons, much like the insects that fly. They do have them, but they're light, not as heavy, so that they allow them to fly. We can't fly mainly because our skeletons are very, very heavy, guys. They allow us to walk. Walking is you might undermine walking until us people who could before and probably were involved in an accident, or when maybe you hurt your leg someday and you can't even move it, then you would appreciate what a big deal it is to walk. It's not just an easy thing. For people who have been involved and are now undergoing physiotherapy, it's difficult to get back to that routine of walking. Easy task. And those are it's amazing the adaptations that occur. They are, our bones are heavy, so we need to adapt in that certain way. Ne? That's how we differ from organism to organisms. Animals that support their bodies clear off the ground needed an energy efficient way of maintaining balance. For this reason, the leg bones of most animals are held directly underneath the body. In this position, props or struts, and it is the bones rather than the muscles that take the most of the strain of the body's work. So yeah, like I will mention again, study the different animals, study their structure. Look here, the land vertebrates often have legs placed directly beneath. That's why the four-legged animals, they have their, because they'd be here. Even elephants, you see how big they are. An elephant wouldn't survive on two legs. How would it even move? How would it carry all that weight? But because of the forelegs, it provides that support that is needed on all sides. Then it can be able to exist nicely. The legs are placed directly beneath the body. The leg acts as struts, and they are the most energy efficient way to keep the body suspended above the ground. With the animals, the body is suspended above the ground and the legs are down there. Guys, any questions so far? I feel like I was flowing now and then I forgot about you. Tell me, any questions? You are most welcome. Like I told you, any discussions? We are here. I am here. This is what you need to know and understand. To serve you. I am here to make life easy for you. So you need to suggest to me ways that will help you work better, that will help you understand better. If you have questions, tell me, because I am here for you. So use me in any way possible. If you want to ask million questions and whatever, okay. For as long as I know that you will be learning and it will help you in your work. Okay, guys, that will be it from me today. I will leave it here. If you have any questions, do let me know. If not, I don't know. But yeah, I'll see you again tomorrow, guys. Thank you so much. If you have any questions, don't worry, you can still ask me. I'll give you like a minute or two to provide the questions. But if we will meet again tomorrow.